Okay, so this module is for file systems. Let's see. Okay, so the idea is that to let you know that there are different technologies for hard drives and file systems, and that we have another technology here in Setonix. So basically, as I said, the idea is to have a fast connection between the compute nodes and the store and the disks. I think that's the main thing, and also to make it available to all the users and to all the nodes at the same time. That's in terms of the hard drives. Now the hard drives are sort of partitioned in different pieces. What is the Lustre or fast file system is partitioned into pieces. One is Scratch and one is software. I already mentioned them. So Scratch is where you save all your data, and software, as the number says, is where you install your own software to be used. Acacia is the object storage to have long storage for your data and configurations files in home. There are some other file systems that are not access to everyone, the Astro and the ASCII buffer. Yeah, for Scratch, it's 15 petabytes of capacity. I already mentioned this. I don't know, this is not about the SSDs, but there are limits, so you cannot fill them up in terms of the there are limits per project. So those 2 petabytes per project is maximum, or 2 million files per user. That's the maximum you can use. So this soft limit is basically you will start receiving warnings if you are reaching the soft limit to let you know that it's better to keep your data in Scratch below that. But the hard limit is to allow from here to here for the simulations to keep running and keep generating data without affecting your research. But the idea is to keep your data below the soft limit in Scratch. So you can access it via the my Scratch environment variable, and files are purged every 30 days. So be mindful, delete your own files. Now, there is an object storage named Acacia, where you can save your data and keep it there for the entirety of your project. By default, projects have 1 terabyte of allocation, but it can be expanded if you need to. It's different from Scratch, and it's different from any file system that I knew before. So it is completely different. The object storage, there is a whole presentation for that. You need to understand how different it is and how to basically retrieve data from there and put data there. But anyway, it's important at this point to know that that is the place where you store your data for more permanent use. And software is where to install software. So if it is software that is going to be used only by you, you store it where the my software variable points, which is software. Then we have this additional directory named projects, and then the name of your project, and then your name. If the software is going to be used by many members of your project, then it is better to install that software in the level above from your username. So it basically in software projects and the project ID and make it available to everyone. And that is not purged. And there are also quota limits for software. Your home file system. Well, one thing that is important is many times if you, for example, if you are installing software, even if it's installed in software, the files have the file ownership goes to yourself, and instead of the group of your project, it's also yourself. So it is only owned by you, and then our system will identify those files as the quota limit for you in your home directory. So there is also a quota limit for number of files in home. It is a very, very small quota. And so in our documentations, we tell you how to install software and be careful of not hitting this quota. But it is important for you to know that many times if the files are owned as user and as group only by you, that will hit this quota. And yeah, the rest of this is that home is a place where the configuration files reside, is a directory needed by the Linux file system, basically to configure your account, etc. So it's an important place where you put some configuration. And also, I'm very used to use the symbol, the curly symbol, rather than the environment variable. So for example, if you want to go home, you can do cd and then the symbol, and you can go there. Or even the cd without anything will take you home. But if you want to go to a directory that you have in home, name, I don't know, my data. So you can do cd curly symbol / my data, and then you go there. So it is very handy. It's much more shorter than writing the whole environment variable in your cd command. Okay, this is a demo file. Okay, so we are talking about the file systems and that there are limits in the file systems. So you can check how is your quota going for home with the quota-s command. And you can check how is your quota going for software and Scratch using the command that we provide, Pawsey account balance -s, or also the LFS quota. So the plan here is to check that by yourself. Well, I'm going to do the demo. So let me exit from here and then connect with the courses. Well, I will use my own. Okay, so quota -s. The limit. So this is the number of files I have. So the quota is 10,000 and I have 3,000. So I'm okay in that. And also this is the space I'm using, 238, and the limit is 1,000. So I'm fine in that. So that's how you can check if you have problems with your quota in home. Again, what I will say is that this is pretty common. Sometimes you work and install things, etc., and you didn't pay attention that your quota is reaching a limit, and then some things will start sort of failing. So it's always to have in mind, probably my quotas are affecting me. The other is Pawsey account balance -s. Pawsey account balance -s. So this command not only provides the information about the quota it's not providing. So at the end, here in the storage information, should be providing information about what is happening with the quotas for the project and for myself in Scratch or in software. Below this, I don't know if you see information for the courses accounts. The other information, the compute information, is to check from the compute information is for the usage of the allocation in the compute node. So this is completely separate from the topic that we are talking, but the Pawsey account balance gives both compute information and storage information. In this case, it's not displaying anything for me, but it should. So yeah, let's check the slide. So here it is. So the storage information that should be providing is one for Scratch and one for software. I'm telling, okay, the project has that many use from this limit. So at this point, it's not displaying, I don't know why. But yeah, that's the idea. I should check that, and probably we will fix that soon. But that's the idea. And for the there is this other command called LFS quota. If you do that age, you will get the numbers in human readable units. And then the -g is for querying what is happening with your project, with your group of Linux, which is the Pawsey project. This is another variable. This is another variable that you can use, the Pawsey project variable. Basically, in this case, for us, it's Pawsey 001. For the training courses, it's courses 01. And then you say which file system you're querying, and then that will give you the quotas either by project on Scratch, by user on Scratch, or by project on software, or by user on software. So you need to use, if you want to check by project, you need to use the -g and the name of the project. If you want to check by user, you need to use -u and the name of the user. And that will give you information for each of the file systems. So let's do that quickly. So it is LFS quota, human units, and then user myself, and then on Scratch. Okay. So here is the hard limit of 2 million files, and I have only 250,000 files. That's how you check what is happening with the quotas there. Any questions? Moving that in and out Pawsey. So there are two modules of moving data. One is this module 4, and the other one is module 11. Module 11 is more related to the use of Acacia, and this one is with the use of the data mover nodes and using Linux commands to directly put things on Setonix. Yeah, so as I said before, and with this and schematic, so to put things into the disk or retrieve things into the disk toward your own institution or your own desktop, you use the data mover nodes. That's the way you go through. So yeah, these are the technical words we are using for putting data. So to put data on Scratch is we call staging, and archiving is to retrieve data towards your own institution or your own workstation. Okay, so basically one way is directly from where you are to the data mover and then go to Scratch, and Scratch can be read, or the Scratch of Setonix or the Scratch of Garawala or the Scratch of Topaz. Scratch is not shared. Well, Topaz is not here anymore. This has been decommissioned, but the Scratch is not shared between Garawala or Setonix. Each of them has their own Scratch. Or from wherever you are, you can put things in Acacia, and then from Acacia, you extract the data, again using the data mover nodes and putting in Scratch for use. And archiving your data, you can, again, is the opposite. Using the data mover node, you read Scratch and take it to your own computer, or using the data mover node, you read Scratch and put it in Acacia and save it there. And whenever you want, you can read it from Acacia to your workstation if needed. But the thing is that the data mover nodes are the one doing the job. Remember, it's not the login nodes. So there is one way to access the data mover nodes from outside. So instead of using Setonix as the name to access the computer, you use the data mover. So data mover is the name of the, if we can say, the computer that can help you move data in and out Pawsey. Okay, and the command for copying, you can use, well, there are two typical commands to use, rsync or the SSH copy or SCP command. So it works like a Linux copy command, but it works in a transfer from one computer to the other. Yeah, so the demo is use SCP to move things. Okay. So here's the example. So SCP my file towards the data mover node, but you need to specify Scratch, your project, in this case, courses 01, and your username, in this case, COU, a number, and then you can transfer the file. In this case, it is transferring this file that is being created locally, just outputting the echo towards a file. So then you transfer my file, you copy it there, then you log in Setonix and you see that the file is there. And you can copy it back, so you can do it backwards, SCP COU a number at datamover.posi.au from Scratch courses 01 COU a number and the name of the file and the destination, which is going to be where you are standing in your command, the current directory, and the name of the file. In this case, you are renaming the file to be Filesystems. Once the copy is done, you can do an ls and you have the original file, my file, and the file is back. Basically, that's the thing. So here's an exercise. You can do this. Create 3 files, start them into one archive file, and then use SCP to copy the file. SCP the file and copy it to your project and check that everything is working. So SCP also work for copying directories. Yeah, thanks, George. Yeah, so you need to use SCP-R, which means recursive copy. So that copies your directories too. And important is that SCP always needs a source and a destination path. And if you don't put all these paths, it's probably going to try to copy it to your login, well, to your home directory, which is not good. We never want to have things, data in our home directory. Unless you are copying something that goes there, then I guess you can skip this. But usually it's very important to put. And if you put a wrong directory that toward where you don't have access, obviously will return with an error message that file couldn't be copied. Okay. So this is the result of the exercise. Yeah. Okay, archiving data. Well, it's exactly the same exercise. So archiving means extracting data from Setonix and putting it, in this case, in your own workstation. So in this case, it's an SCP from somewhere in Setonix. Although in this case, you need to use data mover. There is a, I don't know, a simplification here, but remember it's data-mover.pawsey.org.au and the destination. So remember always to have a destination. If not, you will have an error in the SCP. So if the destination is the place where you are, the current directory, you need to specify the dot. These dots are usually overlooked when you are checking documentation, etc. But this dot means something. It's the current directory. Okay. Okay, so the copy partition. So we haven't talked at all about partitions, but the supercomputer nodes are organized within the supercomputer as partitions. So this organization is an organization coming from the scheduler, the thing that manages the jobs, when to run them, where to run them. So the organization is in partitions. So we are grouping the nodes in specific groups called partitions. And there is one called copy. So those nodes are the ones that should be used for transfers when you are in Setonix, working in Setonix. So that's important. I guess we are going to come to the partitions later, but it is important for you to know that you should not be using the login nodes for transferring files, and you should not be using the compute nodes for that, because even if you have access for the compute nodes because you have the uh, yeah, you have been granted with access to Setonix and you have time for compute nodes and you can use them for whatever you want, really. But the idea is to use these compute nodes are so specialized that to use them for anything but computing is a waste of resources. So big file transfers should be performed in the nodes, specifically target for that, and those you can find them in Setonix with the partition copy. Okay, and yeah, we will talk about partitions in some further presentations later.